In this lesson, we will delve into the 6-point location principle within the context of fixture positioning in Project 2. The 6-point location principle is a fundamental theory in machine tool fixture design. It plays a crucial role in understanding how workpieces are positioned within fixtures and in ensuring machining accuracy. The 6-point location principle is a fundamental theory in machine tool fixture design. It plays a crucial role in understanding how workpieces are positioned within fixtures and in ensuring machining accuracy. We will thoroughly analyze the core aspects of the 6-point location principle, learning how to restrict the degrees of freedom of a workpiece through the strategic arrangement of locating points. Additionally, we will examine real-world cases in aerospace component machining to appreciate the rigorous quality control spirit involved. In a spatial Cartesian coordinate system, any rigid body has 6 degrees of freedom. These include translational degrees of freedom along the x, y, and z axes, represented by x, y, and z, respectively, and rotational degrees of freedom around the x, y, and z axes, represented by x, y, and z, respectively. For example, a cube placed on a table can move forward and backward, x direction, left and right, y direction, and up and down, z direction. It can also rotate around the axis in these 3 directions. The 6-point location principle states that to fully determine the position of a workpiece in space, 6 locating support points are required to restrict the workpiece's 6 degrees of freedom. Specifically, locating points are arranged on the x, y, and z coordinate planes. The meanings corresponding to the symbols and the illustrations are shown in the figure. Content of the 6-point location principle. The 6-point location principle states that to fully determine the position of a workpiece in space, 6 locating support points are required to restrict the workpiece's 6 degrees of freedom. Specifically, locating points are arranged on the x, y, and z coordinate planes. Arrange 3 non-collinear locating points on the xy plane. These 3 points can restrict the workpiece's translational degree of freedom in the z direction and its rotational degrees of freedom around the x and y axis. For example, if we place a rectangular workpiece on a plane, the 3 locating points on this plane act like 3 legs supporting the workpiece, preventing it from moving up and down, z, and from rotating around the x and y axis, x, han. Arrange 2 locating points on the xz plane. These 2 points can restrict the workpiece's translational degree of freedom in the y direction and its rotational degree of freedom around the z axis. Continuing with the example of the rectangular workpiece, the 2 locating points on the side restrict the workpiece from moving left and right, from rotating around the z-axis. Arrange 1 locating point on the yz plane. This point can restrict the workpiece's translational degree of freedom in the xy direction. The final locating point determines the workpiece position in the forward and backward direction, x direction. Box-type workpiece, the bottom surface, OXY, is restricted by contact with 3 locating points. The side surface, XOZ, is restricted by contact with 2 locating points, and the end surface, ZOI, is restricted by contact with one locating point. 2. Disk-type workpiece. The large end face of the workpiece is restricted by contact with locating points 1, 2, and 3. The cylindrical surface of the workpiece is restricted by contact with locating points 4 and 5, and the groove of the workpiece is restricted by contact with locating point 6. 3. Shaft-type workpiece restricted by 4 locating points 1, 2, 3, and 4. Reference pin 5 and thrust pin 6. In the machining of aerospace components, the 6-point location principle is applied rigorously. The machining precision requirements for aerospace components are extremely high, and any slight error can lead to severe consequences. For instance, when machining critical parts of a rocket engine, a fully constrained method is employed to ensure that the precision of each locating point meets the zero-error benchmark criteria. Each locating point serves as a quality defense line, embodying a meticulous craftsmanship spirit. Since the engine components operate under high temperature, high pressure, and high-speed conditions, inaccurate positioning may result in insufficient fitting precision of the components, thereby affecting the engine's performance and reliability. In automotive manufacturing, the 6-point location principle is also widely applied in the machining and assembly of automotive components. For example, when machining an engine block, it is necessary to precisely position the block to ensure the dimensional accuracy and relative positional accuracy of each cylinder. By arranging the locating points appropriately and using either fully constrained or partially constrained methods, different machining requirements can be met. In practical applications, the selection and the design of locating points are very important. The position, shape, and number of locating points will affect the positioning, accuracy, and the stability of the workpiece. Locating points should be chosen on the primary reference surfaces of the workpiece, ensuring the precision and the surface quality of the locating points. For instance, when selecting locating points, factors such as the structural characteristics of the workpiece, machining processes, and precision requirements should be considered. Additionally, the design of locating points should facilitate manufacturing and maintenance to reduce production costs. Although the 6-point location principle is the foundational theory for fixture positioning, it does have certain limitations. In some special machining scenarios, such as in flexible manufacturing systems, the shape and the size of the workpiece may change, and the traditional 6-point location method may not meet the requirements. Therefore, in recent years, some new positioning theories and methods have continuously emerged, such as sensor-based intelligent positioning technology and adaptive positioning technology. These new technologies can automatically adjust the positioning method according to the actual condition of the workpiece, enhancing the precision and flexibility of positioning. In this lesson, we studied the 6-point location principle within the fixture positioning principles of Project 2. First, we understood the concept of degrees of freedom, recognizing that any rigid body in space has 6 degrees of freedom. Then, we explained in detail the content of the 6-point location principle, which involves restricting the 6 degrees of freedom of a workpiece through 6 locating support points. Next, we introduced the classification of positioning methods, including fully constrained, partially constrained, under-constrained, and over-constrained positioning, clarifying that under-constrained positioning is not allowed, and over-constrained positioning may cause issues. We also examined practical cases such as aerospace component machining and automotive manufacturing, observing the important applications of the 6-point location principle in industrial production. Finally, we mentioned the limitations of the 6-point location principle and the new directions for its development. I hope that through this lesson, everyone has gained a deeper understanding of the 6-point location principle, laying a solid foundation for the subsequent design and application of machine tool fixtures.